Hello, grade 12 Mindsetters, and welcome to it. This is your proudly sponsored by Learn Extra Live. You know, mindset. That's how we do it on Saturday. It is a Saturday live, especially for you, grade 12s. We cannot disappoint you. We're doing maths today, and I'm not alone. My name is Abram, and I'm with Wilson. Wilson, how are you? I'm
doing well. Great. Yeah.
The Mindsetters have been talking about you. You know, since Monday, they're like, "Where is Wilson?" So finally, you're here.
Yeah. We're here to do trick, guys. I've question papers, one of the Prelim paper. I hope you guys have a question. You have a paper with you and a pen. Try to do the problems with me. Don't just look, don't observe me. Try to solve them with me. Okay, guys? I hope you're ready there. Okay?
I like that. Don't just observe, work with this, because practice makes perfect indeed. In the meantime, download your notes on our learnextralive.co.za/live. I'll also post them on our Facebook page. If you don't know it by now, you should be knowing it. It is facebook.com/learnextra. Like the page, get your friends talking, help other mindsetters also on the page, because currently we're having over 51,000 likes and people talking on our page. So get on Facebook, and learning couldn't be easier than that. Otherwise, you can also follow us on Twitter @LearnExtra. For now, let's learn more Learn Extra. Wilson, take it away.
Thank you, Abram. Okay, guys. I have a question that I'll be solving now, guys. What I'll advise you guys, before you tackle any problem, read the whole question. And if you have 1.1, 1.2, 1.3, and you can't solve 1.2, skip it. Solve 1.3. You'll come back later. So I have one problem here with me, guys. Question 1. We've been given that cos 64 equals to m. What is cos? Cos is adjacent over hypotenuse. In this case, it's adjacent over hypotenuse, but this equals to m. So m can be written as m over 1. So it implies we can have a right angle triangle with 64 degrees, where this is the adjacent. The m can be the adjacent, and 1 can be the hypotenuse. Okay, guys. Let's look. What do we have here? With the aid of the diagram, the aid of a diagram is very important. You have to draw the diagram. You have to have the diagram. Determine the following in terms of m. With the aid of the diagram, we need a diagram. We need a diagram. With the aid of the diagram, determine the following in terms of m. Very important. Can I take this? Let's look at the problems. This is the problem we have. We have to determine this with the aid of a diagram. Can I take these problems and put them on a calculator? Yes, I can do that. But is that correct? No, it's not correct. I can do this. I can take 64 and put it on the calculator, but that's incorrectly. That's wrong. Let's look how we can solve this, guys. My first problem, I have cos 64 is equals to m over 1, and m can be written as 1 over m over 1. So where cos 64, why do I draw this in the first quadrant? Because 64 is in the first quadrant. You have 0, we're rotating that way. We have 0 there and 90 there. So 64 fall in the first quadrant. So cos 64 is 1 over m. What is cos? Adjacent over hypotenuse. So I can say adjacent, because this is the adjacent, the x-axis, and the radius in this case is 1. Try to complete a diagram. Then what can I do? What is missing? I have a right angle triangle. The adjacent is m. The hypotenuse is 1. What can I do to find the missing? What do you think? I can use what? Pythagoras. Let's see. Let me use Pythagoras. Let's see what I get. If I use Pythagoras, I have x squared plus y squared is r squared by Pythagoras. What is, I want y, the y-axis. So y squared is r squared minus x squared. Good, fantastic. This is beautiful. What is r? It's 1 squared. What is x? It's m squared. Then if I square root both sides, I get y equals to the square root of 1 minus m squared. So implies this is 1 minus m squared. Actually, if you square it, you get plus minus, y equals to plus minus the square root of 1 minus m squared. But because the y-axis, this is positive, I take the positive 1. Now, let's see what can I do with this. I've turned 64. I can use this diagram because I have 64 there. And I also have 64 there. Then I can use this. What is tan? Tan is adjacent over hypotenuse. So this would be adjacent with this m over tan. Sorry, it's not adjacent over hypotenuse. Tan is opposite over adjacent, which is my opposite, which is that. Opposite, adjacent. So I'll get square root of 1 minus m squared over m. Great. I hope you can do this, guys. What do we do? What do we do in this kind of problems? We've been given that cos 64 in terms of m. We have to draw the diagram. Since we have cos 64, you can determine anything with the angle 64. In this case, you can solve anything of 64. I hope you understand. This is beautiful. This is good, guys. Let's see the next problem. Next problem. What do we have here? Is that with the height of a diagram again, we already have this. So we already have this. This is x. This is y. This is my m there, and this is square root of 1 minus m squared from the previous problem. What can we do in this case? I have 32. I have 32 and 32. I can't use this in this case because I have 32 and 32. I need what? 64 to use this diagram. But what can I do? Remember, your compound and your double angles, you can use them. If you look at your formula sheet, we have something like this. Sine 2a is equals to 2 sine a cos a. From the formula sheet, you can get this from a formula sheet. What can I do with this? So I have 2 sine 32 cos 32. I can transform this into that. How? I can say this is sine 2 times 32 degrees. Agree, guys? How do I do this? Because this is 2 sine 32 cos 32. Then from the formula sheet, I have sine 2a. This is 2 sine a cos a. You can reverse this. So from there, you can move backward to there, which is sine 2 times a, provided this is the same as that. So from there, I get sine 32 times 2 is 64 degrees. So I have sine 64. Then I can use my diagram to determine sine 64 in terms of m. Let's see what you have. What is sine? Sine is opposite over hypotenuse. So opposite, there's my opposite. So I get minus 1 minus m squared over 1. So I get the square root of 1 minus squared over 1, which is good. I hope you understand. This is beautiful, guys. I'm so excited. I love this trick. This is most of the beautiful mathematics. I can do this the whole day, guys. I hope you're enjoying this. Okay, let's look at another problem. What do we have there? So the next problem, remember, guys, I can use 1.1 or 1.2 to solve 1.3. The answer you have from 1.1, you can use it for 1.2 or 1.3. Now, let's look at the third problem. We have sine minus 116. This minus, how can I get rid of this minus, guys? Let's look at a Cartesian plane. If you rotate, normally your normal Cartesian plane, you rotate this way, but if you rotate this way, you get minus theta in this quadrant, where this is your cast rule, guys. So minus theta, minus 10 degree. Where's minus 10 degree? It's in the fourth quadrant. Okay, but only cos is positive in that quadrant. So what does it mean? Let's check. So sine minus x. Where's minus x? The fourth quadrant, therefore this would be minus sine x. It follows also, what is cos minus x? Where's minus x? Minus x in the fourth quadrant. Therefore, cos will be positive. So this is cos of x. Okay, guys. So let's see what I can do with this. What I can do with this. So I have minus 116. How can I get rid of that minus? Because if I had minus x there, I can take this out and say this is minus sine 116 degrees, because sine, if minus theta is in the fourth quadrant, and in the fourth quadrant only cos is positive. So I have, good, this first step, this is what you can do. So I have minus 116. Good, this is fantastic. But I don't have minus 116 on my diagram. What can I do? I have 116. I have to try to reduce this. What can I do? I can use reduction formulae. Okay, I can use my reduction formulae. So I think this is minus sine. I can say 180 minus 64. I think I'm correct. Minus 64 degrees. Because 180, let's look. 180 minus 64, you get back to 116. Then where's 180 minus 64? The second quadrant. Therefore, sine will stay negative. Minus sine 64 degrees. Okay. Our diagram from the first question we had 1 minus m squared. And here we have m. So sine is opposite over hypotenuse. So sine is opposite over 1. So which is minus square root 1 minus m squared over 1. Okay, good. I hope you understand this, guys. This is beautiful mathematics. This is fantastic. Abram, do you have any question from Facebook there?
Well, in the meantime, the mindsetters are enjoying the show and saying, as much as you are saying that you can teach the whole day, they can learn the whole day. And I think in that we should just give them a little break.
Okay, great, guys. Let's take a break.
All right, mindsetters, stay tuned, because after the break, we'll still be doing more of your questions, your prelim questions. Also, be on the page, ask us some questions, and holla if you are watching the show. See you after the break.
Right.
Welcome back, Matrix. Now, looking at our Facebook page, which is facebook.com/LearnExtra, we have Timen Tabang Mole, who's saying, morning to all the mindsetters. You know what? I just love that 1.3. So thank you to you, Wilson. And also, Kabelo, DJ KB Mpatele. Welcome, but it's good to see you even on Saturday. Enjoying the show, saying, Maths Paper 1 also went great yesterday. To everybody that wrote, we hope that you also wrote well. Give us some feedback after writing every paper on your prelim, because we're here to also assist you. Otherwise, Wilson, great feedback from the learners. Let's learn more.
Great, great. I hope you read again, guys. I'm back again. I have 1.3, same problem, guys. Let's see what we can do. I have the same problem again. We have a cos. We have the cos of cos 64 equals to m. The same diagram we can use. We had, this was a square root. This was a square root of 1 minus m squared, and this is m. So the question is, determine which is sine 94 in terms of m. Remember, I can use the diagram provided that this angle is the same as that angle. In this case, we have 94 and 64. They're not the same. But what can we do? Let's see what we can do. The previous problem, I had 116. I tried to reduce 116 using reduction formula, which was 180 minus 64. Let's see if we can use reduction formula again. I have 94. What can I do? I mean, if I say 180, what can I do? Minus what is to get 94? If I use 90, is 90 plus 4, which is 94, but I don't get anything, which is of 64. If I say, which because 90, which is 94, but if I say 180 minus 94, I get 86. 86 is not in the diagram. Something. Do you have any idea? You're thinking what we can do here. I think, let's see what I can do. So I have 94. I can't relate this. So, but if you look at them, what is the relationship between that and that? I can say sine 30 degrees. Guys, 30 degrees. This is sine 30 degrees. plus 64. What? I can use my compound and double angles to solve this problem. Y 30 as 64. Sine 30 plus 64. This is a special angle. I can do this from my head, or you can use your calculator. And 64, which I have on the diagram. Now, let's see. What can I do? You can look at the formula. So, sine of this is sine 30 degrees cos 64 degrees. The sine keeps its sign, plus cos 30 degrees, plus sine 64 degrees. Okay, good. From there, I can determine this and that using the diagram. But what about this? I don't have 30, cos 30, sine 30 and cos 30. But I'm happy with this because 30, I can use my special angles. I don't have to worry about this. So let's see what we can do. What is sine 30 degrees? Sine 30 degrees, use a special angle. Sine is 30 degrees, should be a half. Okay? Or you can use a calculator. If I use my calculator, I put here, I say sine 30 bracket, I get a half. So sine 30 degrees is equals to a half. Then what about cos 64 degrees? I can use the diagram. Cos is adjacent over hypotenuse, which is m over 1. What about cos 60? I can also use my special angles, which is, or I can use a calculator, which is cos 30 degrees, which is root 3 over 2. This is root 3 over 2. And sine 64, sine is opposite, cos adjacent opposite over hypotenuse, which is opposite. This is my opposite. Okay, opposite over hypotenuse. Let me erase this. So cos is root 3. This is root 3 over 2. Root 3 over 2. And sine 64, sine is opposite over hypotenuse, which is square root 1 minus m squared over 1. And what can I do? Simplify this further. This is m over 2. If you multiply this, guys, you get, because square root 3 times square root 2, guys, this is the square root of 6. I can multiply the square roots together. Okay, so let me apply the same principle here. So I can say this is the square root of 3 minus 3m squared over 2. The 2, my LCD is the same. So this is m plus square root 3 minus 3m squared over 2. Okay, guys, this is, if you try to reduce and you can't get an angle inside your diagram, I can try to do what? Use my double angle or my compound angle, guys. This is beautiful mathematics. This is fantastic. Abram, do you have any question there particular about these problems or anything?
Not on that one. I have a question based on the previous question 1.3.
Yeah?
Right. It's from Kavisha. Kavisha says, could you have added 36 degrees to the negative sign and got the same answer after reducing it?
Okay. We could have added what?
36 degrees to the negative sign and got the same answer after reducing it. Could
adding 36. I'm not quite sure about that. I mean, you could add 180 degrees to 116, not 36. I don't understand why you're adding 36. What is her name?
Kavisha.
Kavisha. So you have 116. I don't think why you add 36. I mean, just post back to Abram why you add 36. I don't think that's correct. You have to add 180. You can add 180. That will work out. Okay, that's correct. Let's see the next problem, guys. Okay. So the next problem, we have the same diagram, same question. I can complete this. I remember this was 1 minus m squared, the square root of this, over 1. Now, determine this in terms of m. I mean, I don't have 80. I don't have 16. I don't have 10 degrees. I don't have 164 degrees. What can I do? But what I like about this problem, I can see cosine. I can see the then sine. Something clicking there. I mean, your compound angle. You have cos, sine. Remember that. Sine, cos, sine. Let's see what you can do. But remember, this must be the same as that, and this must be the same as that. So let's see what I can do. For now, I'll leave anything less than 90. I'll write cos 80. I'll leave my cos 80 as cos 80. The cos 16 degrees. I'll leave everything less than 90. Cos 10 degrees. Leave as cos 10 degrees. Okay, cos 10 degrees. Then, how can I reduce 196? Using my reduction formula. Where is 196? You have 0, 90. Your Cartesian plane. You have 0 there, 90, 180. Where's 196? Second quadrant. Second quadrant, what do we have? 180 minus theta. So we need something 180 minus something that will give us 164. So let's see. I have 164. So 180 minus 164. I get 16. Okay, let's try use it. I'm happy with this. Yes, it's fantastic because I have 16 there and 16 there. This is promising. This is looking good. Let's see what I can do. So this is sine 180 minus 16 degrees. Yes. Then this is cos 80. This is cos 80. I'll write my cos 80. Cos 80 degrees. Cos 16 degrees. Cos 10 degrees. This is in the positive because 180 minus theta is in the second quadrant. Therefore, this is sine of 16 degrees. Sine 16 degrees. Oh, sine 16 degrees. Okay, now I have cosine. What can I do? With a cos double angle, we have cos, sine. You can reverse that. But if you have, and with a sine, we have sine and a cos and a sine. But I have cos, I have cos, sine. What can I do? Let's aim to change this to sine. If I can make this sine, I win. I win this war. But let me show you something. Sine, let's write cos, just keep this as my cos 80 degrees, cos 16 degrees, cos of 10, guys, the cos ratio, cos 30 degrees is equal to sine 60 degrees, because they add up to 90. So cos 50 degrees is equal to what? Sine 40 degrees, because of the cos ratio thing. Okay, so I can change this cos 10 into sine 80 degrees, because of, remember, the co. So this is sine 16 degrees. What can I do? Now I'm happy enough. Cos, sine. I know this is cos. So this must be cos 80 degrees minus 16 degrees. Okay. So I have cos 180 minus 16 degrees. So don't make a mistake. You have a calculator. So you can use this if you want and say, what is cos 80 minus 16 degrees, which is 64. Happy. I have 64 now. Where can I find 64? In the diagram. Then I'm happy now. I feel much better about this. So this is cos 64 degrees. Fantastic. Then I can use my diagram. Great. What is cos 64? Cos is adjacent over hypotenuse, which is m over 1. Fantastic, guys. This is beautiful mathematics. I love this. I hope you're enjoying this and you're trying this as well. Practice maths, guys. You don't look at the problem. You do the problem. We don't read mathematics. You take a pen and a paper and you do the sum. You do it again and you do it again until you get it right. Abram, do you have any question from there?
No questions, just the mindset to say, like Gabriel was saying, I think Wilson just taught me a faster method on 1.5, so which is a good one. I hope they'll use that and pass. But otherwise, a great one before we take an ad break. It's from Shay Ryder, Orlando Pirates Mnisi. Shay Ryder says, wow, I'm enjoying this with Mr. Wilson. Now I'm doing sir, you're doing a very good job. I'm going for a kill this year. I'm going for an A+. Thank you, Wilson. So Shay Ryder is going for a kill this year on maths. But otherwise, we can just continue on that great note.
Okay, great. I think, guys, what is important? I mean, I remember when I did my matric, it was very challenging. It was very difficult. You try. If you can't do 1.1, don't panic spending time doing that problem. Skip it. Do 1.2. Okay, guys. So let's look at if I have another problem here. Okay. So I think this. Okay, let's see. Okay, let's see, guys. Is this correct? I've cos.
All right.
Okay.
Once it is, as Wilson is trying to figure that out, I think I should take this comment from Lerato Chakale, who says, can we just do this the whole day, please? I'm so enjoying this show. So if you are a mindsetter just like Lerato, enjoying the show, but also having some problems, go to facebook.com/learnextra. Give us your problems, give us your feedback also if you're enjoying the show. But in the meantime, let's just take an ad break to chill down a little bit, and we'll come back to more of the questions on your prelim questions. See you after the break. Welcome back, Matrix. Now, we're still learning more right here on Learn Extra. And for now, we are taking you through some of the questions that you have on your prelim, and also to help you on your prelim questions. I'm joined now by Edzai. How are you, sir?
I'm all right, Avram.
Are you ready to learn since it's a Saturday?
Yeah, I hope mindsetters out there are ready to learn. Because remember, maths is to the mind what love is to the heart.
I like that. And talking about that, I shared a quote on the Facebook page saying that learning is a gift, even when pain is your own teacher. Because, you know, some of us are having those teachers. But here on Mindset, we're having the best teachers ever. That's why Mr. Edzai is going to be taking us through some of the questions. Take it over, sir.
Sure, thank you. Okay, Mindsetters, today we're going to be looking at a question that was adapted from the Eastern Cape. So you find that it was from the September 2012 paper 2, right? It was the prelim exams. Now, let's look at what we are required to do, right? The question says, simplify without using a calculator. It's important, extremely important for you to understand the question before attempting to do anything. First of all, understand what you are required to do. So in this case, to simplify, what is it? What does it mean? It means you have to write this very same expression, right, in a simplified form. They're not saying solve anything. They're not saying find the value of anything, but they're saying simplify. So write the same expression, but in a simplified manner. And another key aspect is that I know that with exam pressure, you might not see that it says without, right? So it's important for you to understand without using a calculator. Now, let's get on to the problem. Right. We've got tan 360 minus x, right? I think there was just a glitch here because there's supposed to be brackets over there. So it's tan of 360 degrees minus x multiplied by, that dot, multiplied by cos x minus 90 degrees, of which we're saying the brackets imply that the cos, we're saying cos of the angle x minus 90 degrees, right? plus the cos of 540 degrees minus x. So that is our numerator, and everything is divided by tan of x. Tan of x. So now, before we start simplifying this, let me just take you back so that at least you have some background information on how, what information you can actually use, right? So now, the first thing is we see that there's a tan, right? We see that there's a tan. So the definition of tan is tan x is equal to cos x, sin x over cos x. Okay, that's a common mistake, right? Sin x over cos x. So that's the first fundamental thing that you have to know, right? I hope we're all together there. And then we see now that our angles are not just singular angles, but they are compounded. You see that there's a subtraction and addition, right? Subtraction of angles, yeah. So we need to understand the mathematics of trigonometric quadrants. Okay, so I'm just going to draw you a circle and illustrate what the quadrants are all about, right? Remember, we measure our degrees in an anti-clockwise manner. So we start at 0 here, 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 shares with 0 degrees. And we can continue, right? Because I see that in our question we've got 540 degrees. So I'm just going to continue measuring that. So 360, we're going to have our 450 degrees here, and then 540 degrees there. So I hope you understand what I mean there. Then, the second thing that you have to know about the quadrants is that sine, cos, and tan are all positive in the first quadrant. That is, between 0 and 90 degrees, you have your sine, cos, and tan being positive. Then, in the second quadrant, do you still remember, Abraham, from your high school?
Well, unfortunately, I don't remember.
Okay, all right. No, it's fine. Matrix, remember. Okay, so in the second quadrant, we have sine being positive, right? And then third quadrant, tan, and we have cos. Is that it now, right? That's it. Now, just moving down, we are going to now take down our problem piece by piece, right? Until we get to the solution. Remember, don't rush to the answer. Do it step by step so that you get all the marks that are possible. Okay, right. Now, the first thing that we're going to look at, I'm going to look at it individually, tan of 360 minus x, okay? Right. Now, tan of 360 degrees minus x, right. We're saying, in which quadrant do we get this, this expression, right? In which quadrant? Now, let's go back to our circle, right? That's illustrating the quadrants. Now, 360 is here. If you subtract, you'll be going in the clockwise direction. So if you subtract x, of which we are working on the assumption that x is a value that is not more than 90 degrees, right? So it means that it will lie in the fourth quadrant. Now, in the fourth quadrant, you ask yourself, what is tan? What is the value of tan? Is it positive or is it negative in the fourth quadrant? When you look at it, you will find that only cos is positive, right? So that means that our tan is going to be negative in the fourth quadrant, right? So already we know that we can express tan 360, right, minus x as negative, right? So it's going to be, another way of looking at it, right, is that when you move in the clockwise direction, right, your angles are negative. You understand? Your angles are negative. So you can look at it in this way, saying, my starting point is here at 0, right? And if I move x degrees clockwise, I am going to end up in the fourth quadrant. So in other words, the value of this angle is negative x. So we can rewrite this as tan of negative x, right? So we have changed the format of tan in this case, right? where the 360 now has been converted to a negative x, right? Let's go on to the next one. The next one in our problem is cos x minus 90 degrees. Cos x minus 90 degrees. Right. Let's just write that down. Right. Cos x minus 90 degrees. Right. Cos x minus 90 degrees. Now let's look at that again. Right. There's our quadrant. This is our quadrant diagram. Just going to annotate it in blue so that you remember what it is. Right? Now we're saying we've got cos x minus 90 degrees, right? As we said here, right? Now what do we do? What do we do, right? We've got a cos that is between x, sorry, you know what? Just before I continue, can you just check on Facebook what's happening so that we can get the results? Yes, please.
I'll do that. The Mindsetters certainly are enjoying the show. And Mindsetters, I'm urging you, if you're having any questions based on this question, make sure that you post it on Facebook. Just like other Mindsetters saying, you know what, this is so easy, we can even get a distinction, such as Nom Sanko Sukumbi saying, I'm definitely coming out with my distinction. So if you're still confused, go over Facebook and let us know what are your questions.
Right. Okay, so now, just to continue, remember, we have cos x minus 90. What I'm going to do now is that I'm going to play around with the relationships that cos and sine have. Because remember, sine x, right, it's the same as saying cos of x minus 90 degrees. So if two angles are complementary, right, they're going to have this type of relationship where the sine of x would be equal to the cos of x minus, sorry, it's the other way around, 90 minus x, right? 90 degrees minus x, like that. And also, we can have cos of x is equal to sine of 90 degrees minus x. So, with this knowledge, right, I am going to try and use it, right, to come up with a simplified version of this, right? Now, I also know that negative 1 times x minus 90 degrees is going to give me 90 minus x, right? It's going to give me that. So first of all, I'm going to apply that negative multiplication so that I can have it in this form, right? Because I want it in a way that can help me simplify this, right? Now here I'm going to rewrite this expression and say cos, all right, negative 1 x minus 90, right, like that. So this would give me cos, the negative is going to be out there, negative cos x minus 90 degrees, which is equal to, but remember, cos is a symmetric, right? So negative cos x will be equal to cos x. Remember that, okay? That's why I'm able to use the negative, right? So now, once I've got this, so negative cos will be equal to positive cos. So this is the negative, positive, same thing, right? Cos 90 minus x, like that. Okay, that's what I have. Cos 90 minus x. Just to clarify that, I am using the fact that cos is symmetric. What do I mean by symmetric? If you have to draw the cos graph, right? At the origin here, you'll find that cos of negative 90, right? 90 degrees is the same as cos of 90 degrees. So that's the symmetry that I'm talking about. So I can utilize the fact that negative cos x would be equal to cos of negative x, right? Cos of negative x. So that's the relationship that I'm using here, right? To say cos of negative x minus 90 would be equal to negative cos of 90 degrees, x, 90 minus x, sorry. This is 90 minus x, right? Like that. So we have a situation now where we can say cos of 90 degrees minus x. Let's go back to our rules, right? Where are they? They're here. Remember, it says that cos of 90 degrees minus x would be sine x. So now I know I can replace this with sine x. Okay, so I've done the second one. Now let's go to the next one, which is cos 540 minus x. Okay, I'm still using my circle here, right? 540 is there at the boundary of the second quadrant. Right. Now we've got 540 and we're subtracting x. Remember, x is less than 90 degrees. So it's going to fall within the second quadrant. And in the second quadrant, what is cos positive or negative? From our rules, it tells us that only sine is positive. Thus, cos will be negative. So we can reduce this to cos minus x, right? Cos minus x. So cos 540 degrees minus x can be reduced to cos of negative x. But remember, right? Remember that, minus negative, oh man, right? Minus cos x, right? Because it's negative. So now we've got our numerator. We can now go back to our problem and rewrite the problem, right? Rewrite the problem. I'm just going to put it on the side here. Remember, tan 360 minus x, we got tan minus x, right? So I'm going to write it like that. So this is equal to tan minus x, right? Multiplied by cos of x minus 90. We found that the answer would be sine x. Remember? Sine x. So we're going to write that down again, right? Sine x. And then cos of 540 minus x, right here. 540 minus x would be negative cos x, right? Everything is all over tan x. Tan x is our denominator, our universal denominator. Right. Now, let's take this simplified version and simplify it even further because we still have more relationships that we can use. So, just a second. Right. So, it's tan of negative x, right, multiplied by sine x minus cos x over tan x. Right. That's what we have right now. Next step is to actually now simplify tan, right? Tan. Because remember, tan can be written as sine x over cos x. Right. Now, let's do that. Okay. Right. So we're going to change this now to negative sine x over cos x. The reason why I put the negative out is because there's a relationship that says tan negative x is equal to negative tan x. Okay, so that relationship is always there. So I've taken the negative out. That's why it's there. So your tan is that one. Can you see? So it's negative tan x multiplied by sine x minus cos x. Everything over our denominator, which is tan x. But I'm going to write it as sine x over cos x. Right. So what I've done now is that I have expressed the compound angles, right, as singular angles, and I've also expressed tan x as sine x over cos x. Next, the next step would be to now simplify this whole expression, right, even further. Okay, so remember this is sine over 1, cos over 1, right? Now, negative sine times sine, it will give us negative sine squared, right? Negative sine squared. That's what we're going to get by multiplying these two, right? We'll get a negative sine squared, and our denominator is cos x, right? Cos x, and we've got a negative sign there, subtraction sign here, we edit, right? Cos x over 1. And remember, we've got a universal denominator, which is sine x over cos x. Right. I hope my setters, you're still with me. We are simplifying this. We're taking it slowly, step by step, but this is something that, because of the constraints of time in an exam, you can actually do even quicker. Okay, so, but we're doing it so that you understand the background information step by step, right? Now, the next step is for us now to express the numerator as one fraction, right? So we're going to subtract the 2. So our common denominator in this case is cos x. So I'll write that down, cos x. And my numerator, if you do the cross multiplication, it's going to be minus sine squared x, the negative sign here, minus cos squared x. Right. Those of you who are intuitive are already seeing an identity of some sort there, right? But don't forget that this is only the numerator. We've got a universal denominator, which is sine x over cos x. Right. Now, once we've done that, we can now, remember when you're dividing fractions, right? You invert the denominator and multiply. So this is our denominator, and the one in brackets is our numerator. So what I'm going to do now is I'm going to make use of our identity. Cos squared x plus sine squared x is always equal to 1. That's an identity, right? So it means that if I factor out the negatives, right? If I'm going to have a situation where it's now, our numerator is going to be negative cos squared x plus sine squared x, right? Like that. But remember, this inside the bracket is equal to 1, so the numerator can actually be expressed as negative 1. So I am going to now rewrite it for your convenience. This is negative 1, right? Negative 1. Let me just extend my page, right? And then don't forget about this denominator. It's cos x. And then we're going to now multiply by our denominator, okay, which is now cos x over sine x after inverting. Right. Now, I think we've actually reached our answer. We just have to finish off with the factorization, with the crossing out of equal terms. So in this case, cos x and cos x cancel out, and our answer will be negative 1 over sine x. So that's our final answer, and I hope that you've been following. Let me just do a high-level overview of what I've done here so that at least you might remember the steps, right? So here's what we did. Our original question was tan 360 degrees minus x, right? Oops. Right. Tan 360 degrees minus x multiplied by cos x minus 90. So remember, it's the brackets there, right? Plus cos of 540 minus x, right? Which is also in brackets, right? So what we did, we expressed these three as singular, right? As singular values in terms of x, right? We did that, and then we went on to simplify tan and expressed it in terms of sine and cos, which we did successfully, right? Then after that, we simplified by crossing out like terms and also using our identity, sine squared plus cos squared equal to 1, and we got our answer. So I hope that this was helpful to you, and I hope that you are now at the peak of your preparations for the matric exams, because this is the time when you determine your future, and I know you can. Even if you have been struggling. You still have those few days to actually change your fortune. Thank you.
I like that. That's so inspirational. And also, thank you to all the mindsetters that are helping other mindsetters on the page. Clarence, Noltando, Olivet with the answers. Thank you, Olib, Bantu, Litlojane. Thank you so much, mindsetters. Let's keep helping one another on the page. And don't move. We'll see you after the break. Welcome back, Mindsetters, and now it is still that time where we learn more and learn extra. If you still have some questions, go over Facebook. Our Facebook page is facebook.com/learn extra. To all the Mindsetters that are late, I'm warning you, never do that again, and learn not to forget. That's a lesson that I've also learned today. But otherwise, we're joined by Wilson again. Let's take it again.
Okay, guys, I hope you're ready again. I have an identity in front of me. This is beautiful, guys. I promise you guys, life is good for two things: learning mathematics and teaching mathematics. I think life is good for me today. Okay, let's see what you can do. Okay, I have an identity to prove here, guys. Okay, so how do I solve identities usually? I try to change everything into sine and cos. Then from there, I can try to multiply, play around. But in this case, everything is changed into sine and cos. But what can I do? I see two. I have two sine 2x. That is a compound. I can use my double and compound. Also, cos 2x. Let's see what we have. If you look at your formula sheet, you should have something like this. Sine of 2x. You must have sine 2x's. This pan. Sine 2x is equals to 2 sine x cos x. So I can use this. This is sine 2x. Sine 2x. So I have 2 sine x plus 2 sine x cos x. And this is over 3 plus this span plus 4 plus 3 cos x minus cos 2x. Okay, Abram, can you check if you have any question on Facebook there before I continue this problem? I can sort out my pen and see what is wrong.
All right, while you're setting out your problems, let me give them a link so that they can help do the question with us. Mindsetters, I have posted the question that we're currently doing now on our Facebook page as an image. You can download that picture and learn more with us. Otherwise, download your notes on learnextra.co.za/live. That's how we do it, and it's all for free. We're here to help you, and it's all for free, Mindsetters. And also looking at some of the Mindsetters that are on the page, we have Penyo Musipelo saying, I'm enjoying the show. It's really helping me. I'm going to bang my metric with this. So thank you very much, Mindsetters. Let's learn more.
Okay, guys, I think I'm ready now. Let's look at it. I've left hand side and right hand side. I have to prove the complicated side that equals to the right hand. So I took left hand side because more complicated. I can play with that side and prove that it equals to the right hand side. So what I have is a 2 sine 2x equals to 2 sine x cos x. So I change sine 2x into 2 sine x cos x. Okay, so I still have my 4 there plus 3 cos x. Now I have minus cos 2x. What can I do? If you look at it on your formula sheet, you should have something like this. Cos 2x is equals to cos x squared minus sine x squared. Also, you have that this is 2 cos x squared minus 1. And the third one is 1 minus 2 sine x squared. So I have 3 identities, which is this one and this one and this one in place of this. Which one should I use? I mean, I have 3 choices. How do I know the right one? The all right, but what is the right choice? I think I will go with this choice. Why this? Why do I take this? Because I have cos only there. If I had sine there, I'll take the sine one. Because if I had sine here, I'll take the sine one. Because I have cos, I can use the cos one. So minus bracket 2 cos x squared minus 1. Okay, what can I do? I can distribute the minus. So I have 2 sine x, 2 sine x, 2 sine x plus 2 sine x cos x over 4 plus 3 cos x, distribute the minus, I get minus 2 cos x squared plus 1. Okay, so distribute the minus there, then I try to add like terms. I think on top here, I can try to factorize. What is a common factor? I see a common factor, which is 2 sine x. 2 sine x. I can take out a common factor there, which is 2 sine x bracket. What is left? 1 plus cos x. Then on bottom, I can add my like terms. I keep this first, which is minus 2 cos x squared plus 3 cos x, and 1 plus 5, 1 plus 4, I get 5. Okay. What can I do in this case? I mean, I factorize that. I have minus 2 cos x squared plus 3 cos plus 5. What kind of expression is that? It's quadratic. I mean, just imagine you have x squared plus x plus 1. Well, the cos is quadratic. I can try to factorize this. Okay. Let me take out minus as a common factor first to make my life easy. So I have 2 sine x plus 1, then the cos x there. And I take minus 1 as a common factor. Minus 1, I have cos x squared minus 3. I change the sign because this is positive. I divide by minus. So which is cos x, then minus 5. Great. Then I can factorize this. How can I factorize it? Let's look at the factors of it. So this is 2 there. If I can do this, try to find the factors of 2, the factors of 2, the factors of 2s, and the factors of 5, such a way they add up to get 3. So I say 2 and 1, the factors of 2. What about the factors of 5? It's 5 and 1. This time this. Cross multiply, you get 5. This time this, I get 2. If you minus, you get 3. Great, I get the middle term. Then I can use this. This is my first bracket, second bracket. So I keep my minus there. So I have 2. I write this whole thing. I need this, which is cos x. Then over, I have a minus there. So my 2 brackets, let's see. I have 2. The first bracket. At 5, 1 and 1. So I'll have cos x there. I'll have cos x there. The sign, I have a minus, then a plus there. What happened? Good, I'm happy now because this and this cancels out. What is left? I have 2 sine x. If I distribute the minus, I get minus 2 cos x minus 2 cos x plus 5, which is, this is cos x, which is the same as 2 sine x over 5 minus 2 cos of x, which is the same as my right hand side. Therefore, you need to conclude there. I think one thing I've done here, you have to pick. I'm picking the right hand side. You have to say, I'm picking the right hand side. I didn't do that. Okay, you're picking the right hand side. Then you take your right hand side and you solve it until you get the left hand side. Therefore, you conclude. Therefore, the left hand side equals to the right hand side. You have proved your identity. So in this case, I've taken my left hand side. This was my left hand side. And I've proved that equals to the right hand side. Therefore, you must conclude that therefore left hand side is equal to the right hand side. Okay, great. I hope you get this. Okay, sometimes this is challenging, but try to use a compound or double to prove this. Okay, Abraham, don't you have any questions specifically about this identity? Oh.
About that one, well, yes. Specifically, Fefe Mutlak says, I think you might have left something. Let's just help Fefe here. Yeah. Fefe says, I think you might have left something because x just after 2x, 2 sine x, cos 2 sine x is equal to 2 sine x.
Cos what?
Cos 2 sine x is equal to 2 sine
cos
x.
2?
Cos 2 sine x.
Cos
2 sine x.
2
sine x.
Sine x
is equal to cos 2 sine x is equal to 2 sine x. Sorry.
No, I don't think so. Cos 2 sine x, cos 2. No, I don't think so. X and x must be. I don't think that's correct. Okay. Okay. Hope you get this identity, guys. You take the left hand side, you simplify the left hand side, actually the complicated side, until you get the right hand side, and you have to conclude. Therefore, the left hand side equals to the right hand side, guys. Okay, good, fantastic. This is beautiful. Doing mathematics on Saturday. Mathematics. Life is good for two things: teaching mathematics and learning mathematics. I'm having a good life here. Okay, great,
I like
guys.
That. Here's a question for you based on the identities before we move. Gabriel asked me earlier on, saying, can you ask for me about the restriction on an identity?
Okay.
For example, when they say for which value of x is the identity invalid?
Invalid.
Yes.
Good question from Cabello. Let's look at for which value of x will the identity be invalid? Okay, let me try to answer this problem, guys. Okay, so in this case, let me use this same problem. Okay, let's start with this. Let's say 4 plus 3, 4 plus 3, 4 plus x over 1 minus x. Let's look at this expression. For what value will this expression be invalid? Undefined. When do we have undefined? When we divide by 0. When you have 0, a number over something. So this will be undefined if this is 0. If this is 0. And how can we get 0? If x is 1. Because if x is 1, we get 1 minus 1. Then we have 4 plus 1 over 0. And this is undefined. So we have invalid if we divide by 0. Let me look at this example. When will this identity be undefined? This will be undefined if, do this, if this lot is equal to 0, and if this is equal to 0, because we'll be divided by 0, it's undefined, then you solve your general solution. So I'll do one example now about general solution. I hope it makes sense. When you divide by 0, then your identity will be undefined or invalid. Okay? Okay, I hope it answered the question. Okay, let's look at the next problem. So, find the general solution for this. The general solution for this. The general solution. What can I do? Let me advise. If you have sine and cos, like this, you have to try to change both of them into sine, sine, or cos, cos. So you can drop the angles. Let's see what I can do. It's either you can change this into cos, or you can change this into sine, because the idea is that if you have sine, sine 2a, if you have sine 2a over sine a, you can drop the angle such a way you have 2a is equals to a. If the same thing, if you have cos of 2a and cos of a, you can drop the angle. So we have to try to do what? To change this into sine or cos. But I like working with the cos. So how can I change this to cos? Sine 90 degrees by using 90, sine 90 degrees minus x plus 30 degrees is equals to cos 2x, not sine, this should be cos. So I can change this to cos by doing what? By minusing this by angle. Because if you use this, remember, if you use 90, sine changed to cos, and cos changed to sine, then since they're the same, I can drop this lot. I can drop this lot. 90. Distribute the minus. Minus x minus 30 degrees, which is 2x. Great. What is the general solution for cos? If you have the key angle, you just plus minus the key angle, plus, it's plus minus the key angle, plus k times 360. And remember, k is an element of an integer. Let's see what I can do. So from here, what I can do, this is like my theta. So I have 90 degrees minus x minus 30 degrees is equals to plus minus 2x plus k 360. 360 because the period of what? Of a cos graph. If you have a tan here, you lose 180. Now you must say k is an element of an integer in this case. So what can I do in this case? I have plus and minus. I can try to split these two. Let's start with the positive one. Let's solve the one with a positive. So it's 90 minus x minus 30 degrees is 2x plus k times 360 degrees. Great! I took the one with a positive sign because it's 2, it's a plus and a minus. So what can I do? I can move this side, which I get minus 3x because I have minus x. Then I move the 2's, minus 2x minus 3x. Then this plus this, which is 60 degrees, is equals to, I can move the 60 degrees. If I take this and this, I get minus 3x. If I add 90 and this, I get 60, positive 60 degrees. I move the positive 60, I get minus 60 degrees plus k 360. And remember, k is an element of an integer. Let's see how do I get this. I took minus x, which is this side. I move the 2, which changed the sign into minus 2, therefore. Minus x and minus 2, you get minus 3. 90 minus 30, which is 60 degrees. I move the 60 degree this side, I get minus 60. Remember, we need x, so I have to divide by minus 3. X is minus and minus, I get 20 degrees, plus, this doesn't matter, the k, whether you change the sign, because k is an integer. You can keep it as positive or negative, this will still be correct. So, minus k, because I divide by minus, divide this by 3 also, the period change to 120, then k is an element of an integer. So I've solved the one with positive. Let's do the one with the negative. The one with the negative. You see the one with the negative is 90 minus x is equals to minus 2x plus k times 360. K is an element of an integer also. What can I do in this case? I have minus 2 and x. I move this side, so you have minus x. This becomes positive x. I move the 90, it's minus 90, plus k 360. Then I add the 2, then x equals to minus 90 plus k 360. Great, guys. Then I have my two general solution, which is this general solution and this general solution for this problem, guys. I hope you understand this. Let's say you had, you can use sine. You can use, if you go back here, you could change this into sine, then use this general solution for sine. What is the general solution for sine? Remember, for sine, you would do something like this. If you changed everything into sine, let's say sine theta is 0.5. If you find the key angle, theta is 30 degrees. How do I find this 30 degrees? You go in your calculator, you say shift sine 0.5 bracket, you get this. This is your key angle. So for sine, the general solution for sine is this, is a key angle plus k times 360, or theta equals to 180 minus the key angle, which is 30 degrees, plus k times 360. So theta is 150 plus k 360. So what I'm saying, you can still use the sine. You can change both sides to be sine, okay, up there, and use the general solution for sine, okay? Okay, Abram, do you still have more time to do this math?
Yes.
Okay,
yes.
okay.
And I have a simple question.
Okay, yeah.
From Renti Tolo. She says, why do you use a negative or a positive?
Okay. Why do I use, okay, for general solution, for cos, if you change everything into, if you have cos, let me do this again. Let me do this. Let me just give an example. If I have cos, let's say x equals to 0.7. Find the general solution for it. Because I have cos, I have to find the key angle. The key angle, which is approximately, let's see, how do you do this? Clear, cancel everything. Shift cos 0.7 bracket, you get this. You get around 45.6 degrees. Because of cos, the general solution for cos would be x is equal to plus minus the key angle. You always use plus minus, and k is an element of an integer. For cos, you always use plus minus the key angle plus k 360. And if you have sine, you will say your key angle plus k times 360, or what? 180 minus your key angle plus k times 360. I hope I answered the question, Abram. Okay, great.
Can you take another one?
Okay.
From Katleo. Katleo says, why did you leave the 30 degrees when you were doing the negative part for the general solution?
Why did I leave the negative 30? Let's see where.
The 30 degrees?
Where's negative 30? For which part? Again,
for
Abram?
the general solution. Why did you leave 30 degrees when you were doing the negative part?
When I do the negative part, which one is the negative part? Why did I leave negative 30 there? What is happening is that this problem you have, this is like your theta, this is like your theta, this is like your key angle. What do you do from there? Because of, we change everything into cos and cos. The general solution for cos, this will be like your x, and this is your key angle, the plus minus, what do you get there? Then plus k360, okay. Let me try to do another example. Let's see if I can get one problem again. Let me try to do this. Let's say we have sine. We have sine 2x, sine 2x is equals to cos, say 30 degrees. 30 degrees. Okay, look at another example. This is find the general solution. I have to try to change both sides to be the same ratio, provided you don't have anything there and anything, provided you have one. You have 1 and 1 there. So I can change this to cos or sine. I like working with cos because it's straightforward. You just plus minus the key angle, then you're done. So I can change this and say, this is This sine of 2x can change into cos 90 degrees minus 2x is equals to cos 30 degrees. Okay. I can drop this. This is the same as that. Therefore, I have 90 degrees minus 2x is equals to 30 degrees. Because of the cos, what you can do, because cos is straightforward, it's plus minus, you can say 90 degrees, which is like 90 degrees minus 2x is equals to plus minus 30 degrees plus k 360. And k is an element of an integer. This is what you can do, you guys. I hope you understand this. This is beautiful, guys. I hope you're enjoying this mathematics. General solution, trick, identity. I enjoy that. I can do that the whole day. I hope you love this, guys. Okay, do you have anything up from there you want to say? Share with me.
So far, it's just what the mindsetters have to say, and it's just a great lesson after all. Moraka says, I was washing the dishes when I turned into 319, lane extra. I left everything. I took a pencil and a script book, and now I'm doing maths paper 2. So loving you guys. I see an A+ for mathematics this year. So that's awesome. If someone could just leave everything just to watch and learn with this. But otherwise, you said earlier on that life is good for 2 things. Teaching maths and learning mathematics. And life is also good. I see your pen also was doing some, was enjoying. But your last words to all the mindsetters and to all those that are going to be writing their paper 2 on Monday.
Guys, what you can do, you have to study. I believe you can do it. You still have more days to practice your mathematics. Take a question paper, solve a problem, get a study group. I mean, I know there's an intelligent boy there out there. I know there's good mathematicians that can help you. Go there, help other people, do the problems. You learn mathematics by solving problems, not by looking. You take a pen and a paper, you write it down. I hope you enjoy this, guys. Okay, good.
Not just intelligent boys, even intelligent girls.
Just saying. No, yeah, fair enough.
All right. And well, mindsetters, for my side, I just want to say life is good for one thing, presenting a learning show whereby people can learn more and learn extra. I'm having a good show. See you some other time, and peace.
Great. This diagram, because I have 64 there and I also have 64 there, then I can use this. What is tan? Tan is adjacent over hypotenuse. So this will be adjacent with this m over tan. Sorry, it's not adjacent over hypotenuse. Tan is opposite over adjacent, which is my opposite, which is that, opposite, adjacent. So I'll get square root of 1 minus m squared over m. Great. I hope you can do this, guys. What do we do? What do we do in this kind of problems? We've been given that cos 64 in terms of m. We have to draw the diagram. Since we have cos 64, you can determine anything with the angle 64. In this case, you can solve anything of 64. I hope you understand. This is beautiful. This is good, guys. Let's see the next problem. Next problem. What we have here is that with the height of a diagram again, we already have this. So we already have this. This is x. This is y. This is my m there, and this is square root of 1 minus m squared from the previous problem. What can we do in this case? I have 32. I have 32 and 32. I can't use this in this case because I have 32 and 32. I need what? 64 to use this diagram. But what can I do? Remember, you compound in your double angles. You can use them. If you look at your formula sheet, we have something like this. Sine 2a is equals to 2 sine a cos a. From the formula sheet, you can get this from a formula sheet. What can I do with this? So I have 2 sine 32 cos 32. I can transform this into that. How? I can say this is sine 2 times 32 degrees. Agree, guys? How do I do this? Because this is 2 sine 32 cos 32. Then from the formula sheet, I have sine 2a. This is 2 sine a cos a. You can reverse this. So from there, you can move backward to there, which is sine 2 times a, provided this is the
Hello, grade 12 Mindsetters, and welcome to it. This is your proudly sponsored by Learn Extra Live. You know, mindset. That's how we do it on Saturday. It is a Saturday live, especially for you grade 12s. We cannot disappoint you. We're doing maths today, and I'm not alone. My name is Abram, and I'm with Wilson. Wilson, how are you?
I'm doing well. Great, great.
The Mindsetters have been talking about you. You know, since Monday, they're like, where is Wilson? So finally, you're here.
Yeah. We're here to do trick, guys. I've question papers, one of the Prelim paper. I hope you guys have a question, you have a paper with you and a pen. Try to do the problems with me. Don't just look, don't observe me. Try to solve them with me. Okay, guys, I hope you're ready there. Okay.
I like that. Don't just observe, work with this, because practice makes perfect indeed. In the meantime, download your notes on our learnextralive.co.za/live. I'll also post them on our Facebook page. If you don't know it by now, you should be knowing it. It is facebook.com/learnextra. Like the page, get your friends talking, help other mindsetters also on the page, because currently we're having over 51,000 likes and people talking on our page. So get on Facebook, and learning couldn't be easier than that. Otherwise, you can also follow us on Twitter @LearnExtra. For now, let's learn more, Learn Extra. Wilson, take it away.
Thank you, Abram. Okay, guys, I have a question that I'll be solving now, guys. What I'll advise you guys, before you tackle any problem, read the whole question. And if you have 1.1, 1.2, 1.3, and you can't solve 1.2, skip it. Solve 1.3. You'll come back later. So I have one problem here with me, guys. Question 1. We've been given that cos 64 equals to m. What is cos? Cos is adjacent over hypotenuse. In this case, it's adjacent over hypotenuse, but this equals to m. So m can be written as m over 1. So it implies we can have a right angle triangle with 64 degrees, where this is the adjacent. The m can be the adjacent, and 1 can be the hypotenuse. Okay, guys, let's look. What do we have here? With the aid of the diagram, the aid of a diagram is very important. You have to draw the diagram. You have to have the diagram. 16. Good. This is fantastic. But I don't have minus 116 on my diagram. What can I do? I have 116. I have to try to reduce this. What can I do? I can use reduction formulae. Okay, I can use my reduction formulae. So I think this is minus sine. I can say 180 minus 64. I think I'm correct. Minus 64 degrees. Because 180, let's look. 180 minus 64, you get back to 116. Then where's 180 minus 64? The second quadrant. Therefore, sine will stay negative. Minus sine 64 degrees. Okay. Our diagram from the first question we had 1 minus m squared. And here we have m. So sine is opposite over hypotenuse. So sine is opposite over 1. So which is minus square root 1 minus m squared over 1. Okay, good. I hope you understand this, guys. This is beautiful mathematics. This is fantastic. Abram, do you have any question from Facebook there?
Well, in the meantime, the Mindsetters are enjoying the show and saying, as much as you are saying that you can teach the whole day, they can learn the whole day. And I think in that we should just give them a little break.
Okay, great, guys. Let's take a break.
All right, Mindsetters, stay tuned, because after the break, we'll still be doing more of your questions, your prelim questions. Also, be on the page, ask us some questions, and holla if you are watching the show. See you after the break. Right. Welcome back, Matrix. Now, looking at our Facebook page, which is facebook.com/LearnExtra, we have Timen Tabang Mole, who's saying, morning to all the mindsetters. You know what? I just love that 1.3. So thank you to you, Wilson. And also, Kabelo, DJ KB Mpatlele. Welcome, but it's good to see you even on Saturday. Enjoying the show, saying, Maths Paper 1 also went great yesterday. To everybody that wrote, we hope that you also wrote well. Give us some feedback after writing every paper on your prelim, because we're here to also assist you. Otherwise, Wilson, great feedback from the learners. Let's learn more.
Great. I hope you read again, guys. I'm back again. I have 1.3, same problem, guys. Let's see what we can do. I have the same as that. So from there, I get sine 32 times 2 is 64 degrees. So I have sine 64, then I can use my diagram to determine sine 64 in terms of m. Let's see what you have. What is sine? Sine is opposite over hypotenuse. So opposite, there's my opposite. So I get minus 1 minus m squared over 1. So I get the square root of 1 minus squared over 1, which is good. I hope you understand. This is beautiful, guys. I'm so excited. I love this trick. This is most of the beautiful mathematics. I can do this the whole day, guys. I hope you're enjoying this. Okay, let's look at another problem. What do we have there? So the next problem, remember, guys, I can use 1.1 or 1.2 to solve 1.3. The answer you have from 1.1, you can use it for 1.2 or 1.3. Now, let's look at the third problem. We have sine minus 116. This minus, how can I get rid of this minus, guys? Let's look at a Cartesian plane. If you rotate, normally your normal Cartesian plane, you rotate this way, but if you rotate this way, you get minus theta in this quadrant, where this is your cast rule, guys. So minus theta, minus 10 degree. Where's minus 10 degree? It's in the fourth quadrant. Okay, but only cos is positive in that quadrant. So what does it mean? Let's check. So sine minus x. Where's minus x? The fourth quadrant, therefore this would be minus sine x. It follows also, what is cos minus x? Where's minus x? Minus x in the fourth quadrant, therefore cos will be positive. So this is cos of x. Okay, guys, so let's see what I can do with this. So I have minus 116. How can I get rid of that minus? Because if I had minus x there, I can take this out and say this is minus sine 116 degrees, because sine, if minus theta is in the fourth quadrant, and in the fourth quadrant only cos is positive. So I have, good, this first step, this is what you can do. So I have minus 1, determine the following in terms of m. With the aid of the diagram, we need a diagram. With the aid of the diagram, determine the following in terms of m. Very important. Can I take this? Let's look at the problems. This is the problem we have. We have to determine this with the aid of a diagram. Can I take these problems and put them on a calculator? Yes, I can do that. But is that correct? No, it's not correct. I can do this. I can take 64 and put it in the calculator, but that's incorrectly. That's wrong. Let's look how we can solve this, guys. My first problem. I have cos 64 is equals to m over 1, and m can be written as 1 over m over 1. So where cos 64, why do I draw this in the first quadrant? Because 64 is in the first quadrant. You have 0, we're rotating that way. We have 0 there and 90 there. So 64 fall in the first quadrant. So cos 64 is 1 over m. What is cos? Adjacent over hypotenuse. So I can say adjacent, because this is the adjacent, the x-axis, and the radius in this case is 1. Try to complete a diagram. Then what can I do? What is missing? I have a right angle triangle, the adjacent is m, the hypotenuse is 1. What can I do to find the missing? What do you think? I can use what? Pythagoras. Let's see, let me use Pythagoras. Let's see what I get. If I use Pythagoras, I have x squared plus y squared is r squared. By Pythagoras, what is, I want y, the y-axis. So y squared is r squared minus x squared. Good, fantastic. This is beautiful. What is r? It's 1 squared. What is x? It's m squared. Then if I square root both sides, I get y equals to the square root of 1 minus m squared. So implies this is 1 minus, sorry guys, 1 minus m squared. Actually, if you square it, you get plus minus, y equals to plus minus the square root of 1 minus m squared. But because the y-axis, this is positive, I take the positive 1. Now, let's see what can I do with this. I've turned 64. I can use